Here's a question that I located, which is on the Chapter 5-6 homework, the Chapter 5 part of it, on gas mixtures, that has a pretty low success rate, at least the first time students go through it. So I thought it would be worthwhile for us to have a look at it, so you be ready if you hit this. Here's the apparatus. We got two tanks, one 5-liter tank and one 10-liter tank, and they're separated by a valve. The valve between the 5-liter tank, which contains gas A at 9 atmospheres, and a 10-liter tank with gas B at 6 atmospheres is open. What is the final pressure, assuming no temperature change, and that A and B gases behave ideally? Okay. Now, the first thing you should recognize is there is a change. The valve is open. So that means the best thing to do is to use the combined gas law. You can also notice that the number of, if we consider gas A, for example, the number of moles of gas A doesn't change. Gas A just expands from 5 liters up to 5 and 10 liters together here. So N doesn't change. And it says the temperature doesn't change, so this becomes a P1V1 equals P2V2 problem. But we should recognize that this is a gas mixture, and in gas mixtures, we make the assumption that each gas behaves independently, so that there is no effect on gas A caused by the presence of gas B. So we just treat the gases individually, if you will. And what that means is, first of all, P total, after the valve is open, is the sum of the partial pressure of A plus the partial pressure of B. And we could start off by considering A. Gas A by itself at the start is in this 5-liter container. So it's at 9 atmospheres, so P1 of A equals 9 atmospheres. And V1 of A equals 5 liters. Okay? And P2 of A is this PA right here. That is to say, it is the A contribution to the total pressure. So at the end, after we open the valve, P2 of A represents now the unknown for this part of the problem. And what is V2 of A? Once we open this valve, once it's open,
15.
Go ahead. 15, she says. She's right. The gas A now has available to it 5 liters here and 10 liters here, and it will occupy both of those. And so V2 of A will be 15 liters. Okay. So now we go back to this. We solve this for P2 of A. P2 A is equal to P1 of A times V1 over V2, right? And so P1 of A is 9 atmospheres times V1 is 5 liters, and V2 is 15 liters. And if we solve that, we get 3 atmospheres. And so P2 of A, which is the partial pressure of A, once the valve is open, is 3 atmospheres. Is everybody comfortable with how we got that part? Any questions about it? Well and good, because it's all downhill from here. if we look at gas B, we'll treat it just the same way. At the start, P1 of B is 6 atmospheres, and V1 of B is 10 liters. And at the end, when the valve is open, P2 of B is what we need to solve for, and V2 of B, just like A, is 15 liters. So if we solve for this, P2 of B is equal to P1 of B, which is 6 atmospheres, times V1, which is 10 liters, over V2, which is 15 liters. And P2 of B, when I worked that out, I got 4 atmospheres. So what's left to do? Just add them together, right? So P total is equal to PA plus PB, and that is 3.0 atmospheres plus 4.0 atmospheres. All boils down to 7 atmospheres.